Hi, my name is Brandboy F. Tagabuan, and this is ECE37 Performance Task number 7. So let's start. And for our table of contents, for the topic 1, ball grid array, for the topic 2, flip chip, and for the topic 3, thermosonic bonding. For ball grid array or BGA, a ball grid array or BGA is a type of surface mount packaging, a chip carrier used for integrated circuits. BGA packages are used to permanently mount devices such as microprocessors. A BGA can provide more interconnection pins that can be put on a dual inline or plot package. The whole bottom surface of the device can be used instead of just the perimeter. The traces connecting the package's leads to the wires or balls which connect the die to package are also on average shorter than with the perimeter-only type, leading to better performance at high speeds. So these are the BGA ICs assembled on a memory module. So next is the flip chip. Flip chip, also known as controlled collapse chip connection or its abbreviation C4, is a method for interconnecting dies such as semiconductor devices, IC chips, integrated passive devices, and microelectromechanical systems or MEMS to external circuitry with solder bumps that have been deposited into the chip pads. The technique was developed by General Electric's Light Military Electronics Department, Utica, New York. The solder bumps are deposited on the chip pads on the top side of the wafer during the final wafer processing step. In order to mount the chip to external circuitry, either a circuit board or another chip or wafer, it is flipped over so that its top side faces down and aligned so that its pads align with matching pads on the external circuit, and then the solder is reflowed to complete the interconnect. This is in the contrast to wire bonding, in which the chip is mounted upright and fine wires are welded onto the chip pads in lead frame contacts to interconnect the chip pads to external circuitry. So this is the Intel Mobile Celeron in a flip chip BGA package. The silicon dies appears dark blue. And this is the flip chip die attached. And lastly is thermosonic bonding. A thermosonic bond is formed using a set of parameters which include ultrasonic, thermal, and mechanical force energies. A thermosonic bonding machine includes a magnetostrictive or piezoelectric type transducer which is used to convert electrical energy into vibratory motion, which is known as piezoelectricity. The vibratory motion travels along the coupler system, a portion which is tapered to serve as the velocity transformer. The velocity transformer amplifies the oscillatory motion and delivers it to a heated bonding tip. It is akin to a friction bond since the introduction of ultrasonic energy via a bonding tool vertically attached to an ultrasonic transformer or horn simultaneously delivers a force and vibratory or scrubbing motion to the interfacial contact points between a preheated deforming lead wire and the metallized pads of a silicon integrated circuit. At present, the majority of connections to the silicon integrated circuit chip are made using thermosonic bonding because it employs lower bonding temperatures, forces, and dwell times than the turbocompression bonding, as well as the lower vibratory energy levels and forces than ultrasonic bonding to form the required bond area. Therefore, the use of thermosonic bonding eliminates damaging the relatively fragile silicon integrated circuit chip during the bonding cycle. So the picture below entails wires bonded to a silicon integrated circuit using the thermosonic. So thank you so much, and that's the end.